Welcome to 8.2, which is going to be adding and subtracting rational expressions. In the previous lesson, we multiplied and divided, and today we're going to move to adding and subtracting. Now, remember, rational expressions are fractions. And remember, in order to add or subtract fractions, the denominator has to be the same. So that's where things can get a little bit difficult here. What we're going to do first in example 1 is we are not adding or subtracting rational expressions here. We are simply finding the least common multiple. And what that is, the least common multiple is another phrase for common denominator. So when you're going to find a common denominator with your rational expressions, you're really looking for the least common multiple. So in part A here, if 4x squared y to the third and 6x to the fourth y to the fifth were the denominators of two different fractions and I wanted to add or subtract them, I would have to create a common denominator. So how you approach this is really there's two parts. Let's look at the coefficients first. Okay? You want to find the least common multiple of 4 and 6. So if I write out the multiples of 4, 8, 12, 16, on and on and on. I could go further if I need to, but I don't. Then if I write out the multiples of 6, 12, 18, go on forever and ever, which I don't need to. Okay, what I come back to is I look at the smallest multiple they have in common. And so in this case, it's 12. And what that's telling me is that 12 is part of my LCM. Now, in terms of the variables, in order for a variable, whether it's shared or not, will be part of your LCM, okay? In this case, both the x and the y are shared, okay? Since they are shared, you take the variable with the biggest exponent. So with the x's, I've got an x squared and an x to the fourth. The biggest exponent becomes part of my LCM. My y to the third and y to the fifth, because it is the bigger exponent, becomes part of my LCM. And then what you have then, you have this entire expression here, 12x to the fourth, y to the fifth, as your least common multiple. Okay, now, your denominators won't always be monomials like they are in A. A lot of times they will be factors. So we'll have binomial factors. Okay, so if we look at C and D here, all right, the first thing, like we talked about yesterday, is you are always going to factor. All right, so if in part C here, these were two different denominators, we would factor them. This would be x minus 3, and then x plus 1. And then the one next to it, this factors to x minus 3 times x plus 2. Okay, so what we're finding now, we're going to find the LCM, all right, between these two different pairs of factors, okay? So the first thing you look at is, do they share a factor? And in this case, they share x minus 3. All right, that is really similar to what you saw over here when they shared the x's and y's. You take the one that has the biggest exponent. Now, these each have an exponent of 1, so it's the same. So we take x minus 3 to the first power. All right, if there was a different exponent on one than the other, we would take the one with the biggest exponent. Now, what don't they share? Okay, they don't share x plus 1, and they don't share x plus 2, so they both have to be included. All right, so if it's not shared, it has to be included. And so this right here then is my LCM. Okay, so before we have to find a common denominator, let's just simply add or subtract just to remind us on a couple things. All right, so in part A here, my denominators are the same, and I want to add. Okay, so remember when you add or subtract fractions, the denominator stays the same. It doesn't change, but we just combine the numerators. So x plus 5 plus 3x minus 1. Okay? And then we would combine our like terms. So I would have 4x plus 4 over xy. All right, and that would be my final answer for part A. Okay, let's skip ahead to part D. All right, let's say we want to subtract. Okay, same deal with the denominator. If it's the same, it stays the same. And then in the numerator, we subtract. So 3x minus 4. Now, be careful here. You have to distribute that negative sign through the entire expression. Notice plus 1 became negative 1. It became the opposite. Combine our like terms, negative 3x minus 5 over x squared plus 1. And that would be my answer for that. All right, so now we're going to have to add. And our denominators are different, so we're going to have to find a common denominator. We're also going to have to identify any x values for which the expression is undefined. Okay, so we're going to do that part first. So in A here, okay, look at your two denominators. All right, this A cannot be equal to 0. This b cubed cannot be equal to 0. That one I have to simplify a little bit. Cube root each side. B is not allowed to equal 0. Okay, so you got these two. Okay, now I have to find a common denominator. So here's where we look at the LCM. So between 2 and 5, my least common multiple is 10. Okay, now they do not share variables. So if they do not share variables, you have to include each one in your LCM or your common denominator. So this 10ab cubed is my common denominator. Now I have to create that common denominator in each fraction using multiplication. Okay, so I'm going to rewrite the 3b over 2a. What I have to do here is I'm thinking, what am I multiplying 2a by to get to 10ab cubed? 2 times 5 is 10. A times, well, it's already there, so I don't need to change anything with the a's, but I do need a b cubed. Okay. Now, what you do to the bottom, you have to do to the top. Okay, so that is going to come to 15b to the 4th over 10ab cubed. Okay. Now, I have to do the same thing for 7a squared over 5b cubed. Well, this time, what do I have to multiply 5b cubed by to get to 10ab cubed? I have to multiply by 2a. Okay, if I multiply 5b cubed times 2a, I would get 10ab cubed. So multiply top and bottom, and I get 14a cubed over 10ab cubed. Okay, now I have to take these two fractions and I have to add them together. It's asking us to add, right? So I combine the numerators. 15b to the 4th plus 14a cubed all over 10ab cubed. This would be, for this one, our final answer. All right, now let's turn the page, all right, and let's go to this subtraction problem. I'm going to look at part C. And the first thing we're going to do is factor in this case, because I have stuff that needs to factor. So this becomes 2x over x minus 8 times x plus 8 minus 3 over, and that's going to factor to x minus 3 times x plus 8. Okay, now at this point, we're going to find our LCM, or our least common denominator. Okay, so the first thing I'm going to look for is factors they share. Okay, well, they share an x plus 8, so x plus 8 is part of my common denominator. Okay, then what do they not share? All right, well, they do not share x minus 8 or x minus 3, so both of those are in part of my common denominator. So x minus 8 times x minus 3. Okay, so all three of these are part of my common denominator. Okay. Now, how do we create that common denominator? Well, just like we did, all right, in the previous problem, we are going to use multiplication. So for this denominator right here, which factor is it missing? Well, it's missing the x minus 3, so I'm going to multiply it times x minus 3. And whatever I do to the bottom, I've got to do to the top. The result, 2x times x minus 3 all over this x minus 3 times x minus 8 times x plus 8. Okay? All right? Now, over here, what is this denominator missing? It's missing the x minus 8. So I've got to multiply this times x minus 8, both the top and the bottom. Okay, so that's going to result in my numerator, 3 times x minus 8 over, all right, x minus 3 times x minus 8 times x plus 8. Okay, now it's your job to do the subtraction, right? So I'm going to rewrite I'm just going to work with my numerator here for a second. Minus 3. Okay, so there's my numerator. Okay, use your distributive property. So 2x squared minus 6x minus 3x plus 24. Combine your like terms. 2x squared minus 9x plus 24. All my like terms are combined. Bring back your common denominator, and we have our answer. There it is.